Assalamualaikum dan selamat sejahtera. Uh, I am Nur Atira Betty Kamarudin and metric number is 10DDT22F2077 and my three other group mate will make a presentation on the question from the mini project. For the question 1, in this program we take a word input from the user and reverse in it using a stack data struct. A stack is a last in first out LIFO data struct, which mean that the last character pushed onto the stack will be the first on put off. The program first prompt the user to input a word which the store in a string variable. Each character uh, each character of the input word is then pushed onto the stack one by one using a for loop. To reverse the word, we pop characters from the start and print them in the sequence. Since the start operates in LIFO order, this effectively reverses the order of the character. The while pop continue until the start is empty, printing each character in reverse order as it pop off the stack. Finally, the program output the reverse word to the console. For example, if user enter hello, the program will output oleh, OLLEH. This is example for the question 1. If user enter ALI, the input will display ILA to the screen. So that's all for my presentation. Next, I will pass this presentation to my friends.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Majid bin Jafar, number metric 01DDT22F2091. So I will continue our presentation for question 2. So I will explain about the coding for question 2. So for the um, include stream and include string is allow the program to use input/output stream in the stream and string data type. Then second is the main function and constant, int main max pelanggan. And then strings tempahan pelanggan array 5, int bilangan pelanggan, and also int pilihan. So the max pelanggan is a constant that limits the maximum number of customer to 10. Tempahan is a 2D array to store each customer order up to 5 item each. Next is bilangan pelanggan, keep track of the current number of customer in the system. And then pilihan, store the user menu selection. Alright, so then do, which is a main menu loop. Alright, so a do while loop display the main menu, letting the user choose an option. The loop continues until the user choose the exit by selecting option 3. So here's the coding. Count, do, count, sistem tempahan makanan XY restaurant. 1, tambah tempahan pelanggan baru. 2, proses tempahan pelanggan seterusnya. 3, keluar. Then masukkan pilihan anda. So this is the loop menu. And then 4, adding a customer order. For the first one, if pilihan 1. So here's the coding. And the explanation for that is, if the user select one, the program check if the system has room for more customer. If bilangan if bilangan pelanggan is less, then max underscore pelanggan is prompt for the number of food, maximum 5. The entered item are stored in tempahan bilangan. Tempahan bilangan pelanggan. Then bilangan pelanggan is then increment to reflect to the new customer. So next is process to the next customer order 2. So here's the coding. If bilangan pelanggan 0, then this. So the explanation uh, for this one is, if the user select 2, the program check if there are any pending order. If there is an order, the process of the first customer order by displaying each food item. After processing, it shift all other orders up by one position. Then bilangan pelanggan is discriminate to reflect the proceed customer. Then the last one is, uh, if pilihan equal 3, the coding, and then sistem ditamatkan, else pilihan tidak sah, sila cuba lagi, while pilihan 3. So for this one is, if user choose 3, the program output a termination message and exit the loops. So then invalid input handling, for this one, see out pilihan tidak sah, sila cuba lagi. If the user input an option after then 1, 2 or 3, it show error message and loop back to the menu. And then the last one is return 0, is end of the program. The do while loop end with the user chooses to exit option 3. The program then finish by returning 0, indicating successfully execution. So I will show you the output. So this is the output. The output will show sistem tempahan makanan XYZ restaurant. Then, one, tambah tempahan pelanggan baru. Second, proses tempahan pelanggan seterusnya. Third, keluar. So for the first one, masukkan pilihan anda. I choose one. Tambah tempahan pelanggan baru. Then, it will show masukkan bilangan makanan. Maximum of 5. Then I choose 3. So first I choose burger. Second, ayam. Third, kentang. Then the finishing output is tempahan pelanggan telah dimasukkan ke dalam sistem. So that's all for the question number 2. That's all from me. Assalamualaikum.
Terima kasih kepada saudara Majid. Hai, nama saya Nur Adani binti nombor matrik 01 DDT 22F2001. Okay, for question 3, this code implements a binary search tree C++. A BST is a data structure that allows for efficient searching, insertion, and deletion of elements. In a BST, for each node, the left child contains only nodes with value less than the node value. The right child contains only nodes with value greater than the node's value. For coding, structure node, integer data, not left, not right. This defines a node structure which has 3 members. First, data, to store the value of the node. Second, left, a pointer to the left child node, and third, right, a pointer to the right child node. For creating a new node, this function creates a new node with the given value or data and initialize its children to none. For inserting node, this function insert a new value into the BST. It checks if the tree is empty, root equal null, and if so, it creates a new node. If not, it recursively finds the correct position based on the value data. For finding the minimum value node, the function finds the node with the small value in a given subtree. It's keep going left until it finds the leftmost node. For deleting node, this function removes a node with the specific value or from the BST. It handles three cases. If the node has no children or one child, it simply removes it and adjusts pointer. In order traversal, this function prints the value of the BST in sorted order by visiting the left child, then the current node, and finally the right child. And for main function, the main function creates an empty BST, insert several values into it, print them in sorted order, delete a specific value, and print the update tree. And this is the output in order traversal, 70, 70, 40, 50, 60, 70, 80. After deleting 30, the output is 20, 40, 50, 60, 70, 80. Itu sahaja explanation daripada saya serahkan kepada Syahidah. Terima kasih.
Thank you, Adrani, and Assalamualaikum. My name is Ummu Syahidah binti Abdul Rahman, and my matrix number is 01DDT22F2039. So I will continue the presentation with question 4. The first is question 4A, linear search method. Linear search method, a method to find a specific item in a list by checking each element one by one. How it works: start at the first item in the list, next compare it to the target value, and then if it match, return the position. If not, move to the next item and repeat until you find it or reach the end of the list. When to use is good for small lists or when the list is didn't sorted. Okay, next I will explain for this question, and this question needs to be solved, and the target key is 52. Okay, next for this question, there are 9 index and 10 data. We need to find the target key, which is 52, and the solution is to find 52 by making a path counting one by one until we find the target key. And for the first step is index 0 equal at not equal 52, and next index 1 equal 11 not equal 52, and the third step is index 2 equal 19 not equal 52. Then next index 3 equal 25 not equal 52. For index 4 equal 34 not equal 52. Okay, next for index 5 equal 47 not equal 52, and then index 6 equal 52. So 52 equal 52 successfully, and target key found. Okay, next for the question 4B is binary search method. Binary search, a fast method to find a specific item in a sorted list by repeatedly dividing the search interval in half. How it works: first, start with 2 pointers, one at the beginning low and one at the end height of the list. Calculate the middle index. Next, compare the middle element with the target value. If it match, return the index. If the target is smaller, narrow the search to the left half. If the target is large, narrow it to the right half. And repeat step 2, 3 until you find the target or narrow down to 0 element. Okay, next, when to use is only works on sorted list and is much faster than linear search for large dataset. For the target key is 52, and I can see you the solution for this question. Okey, untuk soalan ini pula, step pertama, kita perlu membahagikan kepada 3 bahagian iaitu first, mid dan last. Okey, untuk data ni mempunyai 10 data dan 9 indeks. So, kita kena bahagikan 5-5 lah kan. Okey, di sini middle ialah target kita punya key. So, first ialah index 0 dan mid ialah index 4 dan last index 9. Untuk mid 4 atau 5, index 4 atau 5 boleh. So di sini saya pilih index 4. 52 kecil daripada 52 lebih besar berbanding 34. Sebab saya pilih index yang middle kan. Okey. Lepas tu untuk step kedua, kita sudah ambil 34 tadi kan. So 34 tu okey, untuk yang 34 ni dia sudah kurang daripada 52 kan. Jadi nombor yang sebelum 34 tu kita boleh abaikan dan kita akan fokuskan dengan nombor yang selepas 34 ni. Okey, untuk step yang ketiga ni kan yang sebelum 34 tu kita sudah abaikan kan. So untuk first index ialah 5 dan nilai dia 47 dan last ialah tetap yang sama, indeks yang 9. Middle pun akan bertukar kepada indeks ke-7 sebab kita ada tinggal 6 data kan. Jadi dia kena bahagikan sama rata. Okey. So di sini middle-nya sudah bertukar kepada 55. Jadi kita kena tengok dengan yang target key kita. Target key kita 52 kan, tapi dia kecil. 52 ni kecil daripada 55. So dia tidak memenuhi target lah. Jadi kita boleh abaikan yang 55 ni. Step yang keempat ni kita boleh abaikan nombor tu. Maksudnya 55 ke atas tu kita boleh abaikan, tinggal 2 data lagi. Okey, seterusnya untuk step kelima ni pula kita kena kan tinggal 2 data je kan. Jadi kita kena tentukan di mana last, di mana mid, di mana first. Jadi last bagi data ni ialah di indeks 6 sebab indeks 9 tadi kan kita sudah abaikan di belakang tu. Jadi dia kena anjak ke depan dan indeks tinggal 2 data ni saja. Jadi indeks 6 itu ialah last dan untuk mid ialah indeks 5 dan first ialah indeks 5 juga sebab kan tinggal 2 data. Jadi untuk indeks ni kita kena cari middle kan. Jadi middle nya 47. Tapi 47 ni masih kurang untuk dapat target key kita sebab target key kita 52. Jadi 52 ni lebih besar daripada 47 ni. Jadi kita boleh abaikan yang 47 ni. Kita boleh fokuskan dengan yang satu data ni, okey, untuk cari. Okey, seterusnya step yang ketujuh ialah okey, data tadi kan tinggal satu sudah sebab yang tadi tu kita sudah abaikan 47 kan. Jadi kita kena tentukan balik first, mid dan last. Okey, first, mid dan last ialah di indeks 6 sebab tinggal satu data tu je. Jadi semua akan di situ dan kita akan cari kita punya tu target tu kan indeks middle. Jadi targetnya middle. So middle untuk data ni ialah 52. Jadi 52 sama dengan 52 successfully kan. So target key found. Okey, sekian saja itu pembincangan daripada saya dan rakan sekumpulan saya. Semoga apa yang kami terangkan dan jelaskan mudah dipahami dan bermanfaat untuk kita semua. Dan Assalamualaikum. Sekian, terima kasih.